Trigonometry. Solve equations. What is it? Trigonometry deals with relations between side lengths and angles of triangles and more. Why? Helps in music because sound waves loosely travel in sine and cosine waves, and musicians can follow the patterns that sound awesome. Interesting fact. Some seal species can hold their breath for nearly 2 hours underwater by slowing their heartbeat and conserving oxygen. Now, let's take a look at the examples we're going to discuss in today's video. Let's take a closer look at example 1. Now, let's read the steps. Step 1. Set up the equation. Step 2. Use the unit circle. Step 3. Insert the period to find all solutions. Step 4. Check the other quadrants. Step 5. Combine different results if necessary. Now, let's read the question. Solve the equation tangent of phi is equal to the square root of 3. Let's bring up the unit circle to help us with finding the answer or answers to this equation. Now, let's write down the equation so we can show our work. Our first step is to take the inverse of tangent on both sides, so we can get phi by itself. So now we have phi is equal to tangent inverse of the square root of 3. Well, the next step would be to use the calculator, but we probably won't be able to use one. So let's use the unit circle. We have to go back a step. The result we want is the square root of 3. What argument do we think will give us that result? That's correct, pi over 3, because of the point 1/2 the square root of 3 over 2. Remember, tangent is the y part of the ordered pair over the x part of the ordered pair. So if we divide the square root of 3 over 2 over 1 over 2, the result is the square root of 3. Now, there is one more on the unit circle. What do we think the argument is that gives us the square root of 3 as a result? That's correct, 4 pi over 3. Once again, tangent is the y part of the ordered pair over the x part of the ordered pair, and if we divide the negative square root of 3 over 2 over negative 1 over 2, the result is still the square root of 3. Now, let's write down the answer with this information. So phi is equal to pi over 3. But we need to find all the results in quadrant 1. Since the period of tangent is pi, we need to insert plus pi k, where k is an integer. And we need to find all the results in quadrant 3. So our other answer is phi is equal to 4 pi over 3 plus pi k. In this case, we can combine the two results into one, since they overlap, because pi over 3 plus pi is 4 pi over 3. So our result is phi is equal to pi over 3 plus pi k. Let's graph it so we can see what the function looks like. In this case, we have to subtract the square root of 3 on both sides, so we would have 0 on one side. What do we think is another name for the zeros of a function? That's correct, the x-intercepts. So if we start at pi over 3, each new x-intercept, or 0, is pi away from the last one. That is example 1. Let's move on to example 2. Now, let's read the question. Solve the equation cosecant to the 4th power of 2 theta minus 4 is equal to 0. Before we bring out the unit circle, let's solve for that. Let's write down the equation so we can show our work. Now, there are several ways to solve this. One is to add 4 on both sides and then take the square root on both sides. But we're going a different route. We're going to practice the difference of squares. What do we think the result is if we factor cosecant squared of 2 theta squared minus 2 squared? That's correct. Cosecant squared of 2 theta minus 2 times cosecant squared of 2 theta plus 2. Let's solve for the first case. Cosecant squared of 2 theta minus 2 is equal to 0. Let's add 2 to both sides and take the square root on both sides. So now we have cosecant of 2 theta is equal to plus or minus the square root of 2. Since we're more familiar with sine, let's convert what we have to sine of 2 theta is equal to plus or minus 1 over the square root of 2. And plus or minus 1 over the square root of 2 is the same as plus or minus the square root of 2 over 2. We could take the inverse of sine on both sides, but that's what we would put in the calculator. we're going to use the unit circle to continue. Before we do that, let's solve the other parentheses. Cosecant squared of 2 theta plus 2 is equal to 0. Let's subtract 2 on both sides, and let's take the square root on both sides. So now we have cosecant of 2 theta is equal to plus or minus the square root of negative 2. And that is not possible, since the input of a square root cannot be negative. Let's go back to the first case. Sine of 2 theta is equal to plus or minus the square root of 2 over 2. Now, let's bring up the unit circle. Remember, sine is the y part of the ordered pair. So where do we think we can find either positive square root of 2 over 2 or negative square root of 2 over 2? That's correct. In quadrant 1 with pi over 4, in quadrant 2 with 3 pi over 4, in quadrant 3 with 5 pi over 4, and in quadrant 4 with 7 pi over 4. That means we have 4 answers. Let's solve for each one. First, let's start with quadrant 1. So we can set 2 theta is equal to pi over 4. Remember, the period for sine is 2 pi. So let's insert plus 2 pi k, where k is an integer, so we can find every solution in quadrant 1. Now, let's divide each term by 2. So now we have theta is equal to pi over 8 plus pi k. Let's continue with quadrant 2. So we can set 2 theta is equal to 3 pi over 4. Let's insert plus 2 pi k, so we can find every solution in quadrant 2. Now, let's divide each term by 2. So now we have theta is equal to 3 pi over 8 plus pi k. Let's continue with quadrant 3. So we can set 2 theta is equal to 5 pi over 4. Let's insert plus 2 pi k, so we can find every solution in quadrant 3. Now, let's divide each term by 2. So now we have theta is equal to 5 pi over 8 plus pi k. Let's continue with quadrant 4. So we can set 2 theta is equal to 7 pi over 4. Let's insert plus 2 pi k, so we can find every solution in quadrant 4. Now, let's divide each term by 2. So now we have theta is equal to 7 pi over 8 plus pi k. This could be our answer, but we can actually combine the results into one answer. Let's insert a 1 in front of the pi for our result in quadrant 1. That might make it easier to see the combined answer. What do we think is the combined answer? That's correct. Theta is equal to pi over 8 plus 2 pi over 8k. Or if we simplify, theta is equal to pi over 8 plus pi over 4k. That is example 2. Let's graph the function so we can see what it looks like. In this case, our equation was already set equal to 0. Do we remember another name for the zeros of the function? That's correct, the x-intercepts. So if we start at pi over 8, each new x-intercept, or 0, is pi over 4 away from the last one. Now, it is your turn, so go ahead and pause the video here so you can take your time to answer this question, and I'll show you the results in 3, 2, and 1. Here we found every possible solution, and here's the graph for the equation. Did you get it correct? Awesome. If not, there's always tomorrow.